Dive into 110 must-know concepts necessary for acing the General Machinist Red Seal License Exam. Access comprehensive preparation materials at www.cannycollege.com to ensure you are fully prepared for success. Part 1. 1. Interprets documentation. Involves understanding and analyzing technical drawings, blueprints, work orders, and specifications to determine machining requirements, dimensional tolerances, and part features needed for the job. 2. Plan the sequence of operations. The process of organizing and scheduling machining operations, tool changes, work holding setups, and quality checks in a logical order to optimize efficiency, accuracy, and productivity. 3. Maintains a safe work environment. Encompasses implementing safety procedures, identifying and addressing hazards, maintaining equipment, and promoting safe work practices to ensure a secure workplace for machinists and other personnel. 4. Uses personal protective equipment, PPE, and safety equipment. Involves wearing appropriate safety gear such as goggles, gloves, steel-toed boots, helmets, or ear protection to protect against hazards, injuries, or exposure to harmful substances in the machining environment. 5. Uses hoisting, lifting, and rigging equipment. Utilizes equipment such as cranes, hoists, slings, and rigging tools to lift, move, position, and secure heavy workpieces, machinery, or equipment safely and efficiently in the machining shop. 6. Select workpiece material. Involves choosing the appropriate material such as metals, plastics, or composites based on properties like hardness, strength, durability, and machinability to meet the requirements of the machining project. 7. Performs layout. Refers to marking, measuring, and positioning workpieces, borders, or reference points on materials or components to guide machining operations, ensure accuracy, and facilitate proper alignment during manufacturing processes. 8. Marks workpiece for identification. Involves using stamps, tags, labels, or etching tools to identify workpieces, components, or parts with part numbers, lot codes, or other information for traceability and identification purposes in the manufacturing process. 9. Performs basic heat treatment. Includes heating, cooling, or tempering workpieces or materials using processes such as annealing, quenching, or tempering to alter hardness, strength, or other metallurgical properties for machining operations. 10. Test workpiece materials. Involves conducting material tests such as hardness tests, tensile tests, or chemical analysis to verify material properties and quality, ensuring workpiece integrity and compliance with specifications. 11. Deburr workpiece. Refers to removing sharp edges, burrs, or imperfections from machined workpieces using tools such as deburring tools, files, or abrasive discs to ensure smooth surfaces, proper fit, and safety in the final part. 12. Sketches parts. Involves creating hand-drawn sketches, layout drawings, or rough designs of parts or components to visualize dimensions, features, or tool paths before transitioning to detailed engineering drawings or CAD models. 13. Cleans machines. Involves removing chips, debris, coolant, or residues from machine surfaces, tooling, or components using cleaning tools, brushes, or compressed air to maintain cleanliness, functionality, and safety of machining equipment. 14. Lubricates machines. Includes applying lubricants or cutting fluids to machine components, tooling, or cutting surfaces to reduce friction, dissipate heat, prolong tool life, and ensure smooth operation and accuracy in machining operations. 15. Sharpens tooling. Refers to grinding, honing, or sharpening cutting tools such as drills, end mills, or inserts to restore cutting edges, dimensions, and sharpness for efficient and precise machining performance. 16. Applies cutting fluids and coolants. Involves using lubricants, coolants, or cutting fluids to reduce friction, dissipate heat, improve chip evacuation, extend tool life, and enhance surface finish during machining operations. 17. Troubleshoot equipment. Includes diagnosing, identifying, and resolving issues, malfunctions, or performance problems in machining equipment, tools, or systems to ensure proper functioning, efficiency, and quality in production processes. 18. Maintains machine alignment. Involves checking and adjusting machine components such as tables, slides, spindles, and tool holders to ensure proper alignment, parallelism, and geometrical precision for accurate machining operations. 19. Maintains inspection equipment. encompasses calibrating, cleaning, and maintaining precision inspection tools such as micrometers, calipers, gauges, or CMMs to ensure accurate measurement, quality control, and reliability in machining processes. 2.0 Files Workpiece involves using hand files to shape, smooth, and refine the surface of a workpiece, remove burrs, or correct imperfections in metal, plastic, or other materials. 2.1 Saws Workpiece utilizes sawing tools or machines to cut workpieces into desired shapes or lengths, generating straight or curved cuts in materials such as metal, wood, or plastics. 2.2 Performs hole-making operations involves creating holes in workpieces using drilling, reaming, or boring processes to achieve specific dimensions, tolerances, or hole geometries required for assembly or fastening. 2.3 Performs threading operations involves cutting internal or external threads on workpieces using taps or dies to create screw threads that allow components to be connected or fastened securely. 2.4 Installs thread inserts refers to inserting threaded metal inserts into pre-made holes in workpieces to provide durable and secure threads for fastening bolts, screws, or other components. 2.5 Broaches Workpiece utilizes broaching tools to remove material from workpieces in a linear motion, creating internal or external grooves, splines, keyways, or other specialized shapes with high precision. 2.6 Performs pressing operations involves using hydraulic presses, arbor presses, or mechanical presses to apply controlled force to workpieces, components, or parts for operations such as forming, bending, riveting, or assembly. 2.7 Bends Workpiece involves shaping workpieces by bending, folding, or forming metal or other materials using tools such as press brakes, rollers, or mandrels to create angles, curves, or complex geometries. 2.8 Finishes Workpiece includes applying finishing processes such as grinding, polishing, sanding, or coating to workpieces to achieve smooth surfaces, precise dimensions, desired textures, or protective layers. 2.9 Disassembles Components involves separating and removing parts or components from assemblies, machined parts, or machinery for maintenance, repair, replacement, or inspection purposes. 3.0 Analyzes Components refers to examining, evaluating, and assessing components or parts to identify material properties, dimensions, tolerances, wear patterns, defects, or conditions affecting performance or functionality. 3.1 Assembles Components involves fitting, joining, or fastening parts, components, or sub-assemblies together to construct finished products, machines, or mechanisms following specified assembly instructions or engineering drawings. 3.2 Select drill press types involves choosing the appropriate type of drill press, such as benchtop, floor, radial, or magnetic, based on the size of the workpiece, drilling requirements, and available workspace for a specific machining operation. 3.3 Plans drill press sequence refers to organizing and scheduling the order of drilling operations, including hole locations, sizes, depths, and dimensions, to ensure accuracy, efficiency, and quality in the machining process. 3.4 Select drill press speeds and feeds. This involves determining the optimal combination of spindle speed and feed rate for drilling operations based on the material being drilled, hole size, cutter geometry, and desired cutting performance to achieve efficient and effective drilling results. 3.5 Set up jigs, fixtures, and work-holding devices for drill presses. Refers to installing and aligning auxiliary tools, fixtures, and clamping devices on the drill press table to securely hold and position workpieces for accurate and repeatable drilling operations. 3.6 Sets up tooling for drill presses. Involves installing cutting tools such as drill bits, countersinks, counterbores, or taps into the drill press spindle and chuck, adjusting tool height and alignment to prepare for drilling, tapping, or finishing operations. 3.7 Drill holes using a drill press. Refers to using a drill press to accurately and precisely drill holes in workpieces according to specified dimensions, depths, and hole geometries, ensuring clean, concentric, and properly sized holes. 3.8 Cuts countersinks, counterbores, chamfers, and spot faces using a drill press. Involves using tooling attachments or special cutting tools on the drill press to create conical recesses, stepped holes, beveled edges, or flat surfaces around holes for specific applications and components. 3.9 Performs tapping using a drill press. involves using a drill press equipped with a tapping attachment or tapping head to thread holes or internal threads in workpieces accurately and efficiently with the correct thread size and pitch. 4.0 Finishes holes using a drill press. Includes using the drill press along with reaming, boring, or deburring tools to achieve smooth, accurate, and properly sized holes, removing burrs, sharp edges, or imperfections left after drilling for quality finishing results. 4.1 Select conventional lathe types. Involves choosing the appropriate type of conventional lathe, such as engine lathe, turret lathe, or toolroom lathe, based on the size of workpieces, machining operations, and tooling requirements. 42 Planned sequence of operations for conventional lathes. Refers to organizing and scheduling the order of machining operations, tool changes, feed rates, and cutting depths on the lathe machine to ensure accuracy, efficiency, and quality in the machining process. 4.3 Sets up work-holding devices for conventional lathes. Involves installing and adjusting chucks, collets, centers, or fixtures on the lathe machine to securely grip and position workpieces for turning, facing, drilling, or threading operations. 4.4 Sets up tooling for conventional lathes. Includes mounting and aligning cutting tools, tool inserts, tool holders, drills, or boring bars on the lathe tool post or turret to prepare for various turning, boring, threading, or grooving processes. 4.5 Sets up conventional lathe accessories. Involves attaching and adjusting lathe attachments, such as steady rests, follow rests, taper turning attachments, or knurling tools, to enhance lathe capabilities and perform specialized machining operations. 4.6 Set up the workpiece on a conventional lathe. Refers to securing and aligning workpieces on lathe centers, chucks, or faceplates using clamps, bolts, or other work-holding devices to prepare for turning, facing, or drilling operations. 4.7 Select conventional lathe speeds and feeds. Involves choosing appropriate spindle speeds and feed rates based on material type, workpiece size, cutting tool material, and machining operation to optimize cutting performance, tool life, and surface finish. 4.8 Sets up eccentrics on conventional lathes. Involves installing and adjusting eccentric drivetrains or cams on the lathe spindle or tailstock for off-center turning, eccentric turning, or threading operations to create non-circular features or profiles on workpieces. 4.9 Turns external surfaces using a conventional lathe. Refers to using cutting tools to remove material from the outer surfaces of workpieces, creating cylindrical, conical, or curved profiles with precise dimensions, tolerances, and surface finishes. 5.0 Bores holes using a conventional lathe. Involves using drills, boring bars, or special boring tools to enlarge or create internal cylindrical holes, bores, or recesses in workpieces with accurate dimensions, depths, and alignment. 5.1 Faces surfaces using a conventional lathe. Includes using facing tools or turning tools to machine the flat end or surface of a workpiece, ensuring perpendicularity, flatness, and smooth finish for accurate dimensions and proper fit. 5.2 Turns tapers on a conventional lathe. Involves using taper attachments, compound slides, or taper turning attachments to machine tapered surfaces, cones, or angles on workpieces to precise specifications and dimensions. 5.3 Knurls using a conventional lathe. Refers to creating a textured pattern on workpiece surfaces using a knurling tool or knurling attachment on the lathe spindle, providing enhanced grip, aesthetics, or identification on parts. 5.4 Parts off workpiece using a conventional lathe. Involves cutting workpieces to the desired length, separating or parting off components using parting tools, grooving tools, or cut-off tools on the lathe machine. 5.5 Drills using a conventional lathe. Includes using drill bits, countersinks, or center drills in the lathe tailstock to machine holes, center holes, or counterbores on workpieces for fasteners, pins, or shafts with precise diameter and depth. Dive into 101 must-know concepts necessary for acing the General Machinist Red Seal license exam. Access comprehensive preparation materials at www.cannycollege.com to ensure you are fully prepared for success.